Hello everyone and welcome back to Step by Step Coding and our top 100 C# interview questions deep dive series. Today we are going to touch base one very important topic. What is the difference between value type and reference type? So let's start with fundamental concept as well as the definition. In C sharp, every variable which you declare falls into one of these two categories. One is value type, another reference type. Now in this diagram, the left hand side representing the value types and some of the key characteristics, and same thing for the reference type. Now as the name suggests, a value type directly contains its data. Think of it like a physical box holding a specific number, a character, or a boolean value. Now, another thing is that when you assign one value type variable into another, for example, a equal to b, you get a complete copy of that data. Uh, so you end up having two copy, right? So a equal to b, if you write it, b will have another copy, a will have another copy. So take a look again, this picture, and you see there is a box which is having 42. What actually it means, that box is actually representing a memory location, and the memory location directly contains the data itself. However, if you take a look right hand side, which is a reference types, it's not a simple one single box, rather than it is a two box, and one box is having nothing but a arrow. So what actually it is representing, that reference type contains a reference of another thing. And what is that another thing? That another box is where actually your data is stored. So in other words, imagine that box which is having 42 left hand side, if you replace object with 42, that would represent a reference type where actually your data is stored somewhere else, but you have got a reference. So that is the fundamental difference between value type and reference types. Once again, value types directly contains the data, reference types doesn't contain the data, it contains a reference of the data. Okay, now another thing is that value types lives on the stack, reference types lives on the heap. Now it's very essential to understand what is stack and what is heap. So in next slide, here we are going to understand what is stack and what is heap. A stack is actually a contiguous block of memory. Okay, so it's like a series of the blocks where your data gets stored. Now the idea is that it is very fast. The reason being that there is a definite, there is a sequence you already know. So when runtime goes and allocates the memory, it already knows that where exactly it has to go and store your data, and from where it has to pop out the data, reclaim the data. So that is why the whole overhead is not much, and therefore the reason being that fundamentally it's very the fast. So stack type mainly gets used for the fast, and gets used for the local variables and the method calls, and this is where your value type data gets stored. So int a equal to 5, which is written left hand side, that the a variable and 5 actually gets stored on the stack. Now right hand side is a heap presentation. Heap, think about it that it is a large warehouse which is huge, right? What actually it means that you can store the larger data, but at the same time you can store the data the multiple places. So it's not like in the sequence, it's not contiguous, it's a large space. You can they store data for a longer time, as well as the complex objects, but at the same time there is a overhead, right? You have to manage it, and this is where the garbage collector, right, in .NET concept, garbage collector, this is where kicks in. Garbage collector has to manage the heap, not the stack. Okay, so all the reference data goes on the heap. So person p equal to new person, if you see that person data, right, data of all that person object would be stored on the heap. String name equal to j, again that j the data is going to be stored on the heap. Now keep in mind that the data actually gets stored on the heap, but the reference type, that particular reference, right, that always gets stored on the stack. And that is very interesting to understand, right? So if coming back to this previous slide, if you see in the reference type, you have two boxes, right? So the object, the one which you see, that representing the data that goes on the heap, but the first box which you see, which representing a reference, that is always on the stack. Okay. Now, having said that, now what actually we will do, we will actually deep dive some of the coding section, and we will actually take a look, review some of the C# programs, and we will see that how which variable, which data, right, which goes on the stack, which goes on heap. We will try to understand that when you pass a value type, how it works, when you pass a reference type, how it works, when you do the assignment, how it works. So let's do some the interesting and the fundamental and very interesting objects. Okay, so let's do that. So I'm opening my Visual Studio. Let's try to right away dig in on example one. So here to start with, let me do one thing. I will do what I have done for you folks, that I have actually all these, the C#, the variations, what I have done, I have also created the memory, the memory presentation, that which data will go on stack, which data will go on heap, and it will be easier for us to understand. So let's start with the first one. Pretty simple example. We have two basic, the num1 and num2 value type variables. In num1 it is 5. Now this is a value type. So what actually it means, that the value is going to be stored on the stack. So we have stack here, and this is the num1 one box, which is going to have the start with 5. Then we have second line, which is 19, on we have another num2 equal to num1. So what actually it will do, that it is going to create another box for num2, and then initially what actually it will do, it will put that 5. On the line number 20, what we are doing, we are reassigning 10 into num1. Now keep in mind, take a look here, right? So in stack, what actually it did, it created two different boxes, and like I said, it is a value type, so it directly contains the data. So both will have 5 and 5 to start with. The moment line number 20 is going to be executed, what actually it will do, it will assign value 10 into num1 itself. So it will change the copy of this box num1. But since both are having two different copies, num2 will not accommodate that change, because both are two separate copies. So in this case, num1 will have 10, num2 will have 5. So this is how the value type, memory allocation, as well as a variable assignment works. Okay, so now we will go ahead and we will try to see some different variation. Now in previous example, we saw that how the value type gets assigned. Now here we will see that how the reference type data gets allocated. So in this example, I have actually taken one num1. So what actually it means, that this will be allocated on the stack, okay, to start with, and then we have these two classes. So what actually it will do, it will create it, obviously, this is reference type where data gets allocated on the heap. So what actually is going to happen, the moment C# runtime sees this new, what it does, that it allocates the memory on the heap. So it computes all the data, all the space needed. For example, in this case, we have one integer ID, and then you can have multiple data types, right? So I mean, here it is just a simple, right? But you can have employee name and department name and then salary and all that things, right? So what .NET CLI is going to do, it's going to compute all the storage capacity it's needed, and it is going to create that space. It is going to allocate that space, and then once space would be reserved, right? So we will have an address, right? So this is what it is. So once emp1 is done, right, so you will have 0x200, which is nothing but the memory address, and it will be returned to here, because keep in mind the reference, that reference, right, the pointer is always stored on the stack. So right, so emp1 fundamentally will be on the stack, but the data wise, right, what data would be inside the emp1, that would be a reference, right? So that is going to be 0x200. And same thing, once this line would be executed, we will have another box and it is going to point the employee, and we will have the id too. So simple, the presentation how reference type value works on the memory and in the heap, right? So now we will go ahead and we will review another example, another variation. Okay, so let's say, let's review this example. So here what actually we are doing, we are the first example, if you folks remember, right? So what we did, we actually assigned one value type into the into another value type. Here we are assigning reference type, right? So let's take a look at how it's going to work. So box one, the memory got allocated on the heap. Here you have box 1, you got 0x300. But now on this line, the line 18, what is happening, that box 2 is having assignment, right? So box 1 is getting assigned into the box 2. Now keep in mind what box 1 is having. It is having, the reference, right, 0x300. So box 2 will have 0x300 as well. Now what actually it means? It means that you have two pointers, two reference, and both are pointing to the same data. Now it doesn't matter you use box 1 or box 2, once you change this value, it's going to reflect the changes in both places. And that is why on line number 19, when box 1 dot value equal 10, what actually it will do, it will change the same, it will change the data, and since both are reference, right, pointing to the same data, it is going to reflect it both the places. Interesting, right? So this is how the reference type works. Now let's take a look at another, the variation in example 4. Now this is a demonstration that how when you pass a, the value type, how the data gets passed, right? So let's take a look here. Let's see, we have one value type which we got reserved within the stack, and then we are passing into another function. So each function you gets executed within C#, it gets their own, the memory stack. So that is why this would be another memory stack, and this main method has got their own memory stack. And what actually it means, that all the local variables and parameters and everything within the main method, whatever local variables and everything would be there, it will be stored within this stack space. And then this function, if you have all the local variables, all the, the method parameters and all that things, that would be inside these boxes. So now let's see what is going on here. So we are passing original, which is a value type. Once you pass to number, again, like I said, that this memory stack will have their own number variable, which is here. So initially when 10 was passed, what actually will happen, then this will have the 10, right, the moment it will be passed here. But the moment on line number 16, this number equal to 99, what actually it will do, it is directly, remember, stack directly, contains the, the data itself. So now this will be replaced with the 99. But what actually it means, this is not going to impact this one, because both are two separate boxes, right? Both are having their own copy. So this is the difference, that when you pass a value type to a function, the original, the data doesn't reflect it. Okay, now let's take a look at another variation, okay, quickly. So here we are passing, by reference. Okay, so this is how it works, that this function by reference is getting passed, and reference is having what? Reference is having a memory address, right? So when we pass this by reference to here, what actually it will happen? This will have your memory address, right? So it will have x, the x 0x400. So it's same thing, just like reference type, right? So both are pointing to same data. And now here, if you change any values, it is going to reflected both places. So this is because it's unlike the value type, which is like two separate copies. Since both are the reference pointing to same, the data, change it one place is going to reflect it another place. Now let's take a look another variation here. Uh, what we have got. Okay, so example 6 is actually demonstrating the uh, string behavior. String is a reference type, but it works a little bit different. When I say little bit different, what happens that every time you assign, let's say you have declared a string, okay, and you have assigned a value, but the moment you change that another value, the moment you try to assign to another the string value, what it does that it doesn't change the original data, rather than it always end up creating another instance. And that is why it is the very it is recommended that you try to limit the string, the manipulation string operation as as limited as you can. And we will see, let's take a look. It's very interesting, right? So we have a string s1, we got one box, right, which is having a hello, again reference type. So your data is actually is in the heap, right, and initial memory address was 0x500. Okay, 0x500, I mean this one, right? So let's assume that this was the initial, right, on line number 16. 0x500, you had hello .NET CLR runtime, right? Let's say located space in the heap, and it returns 0x500. This would be returned to this one to start with, right? Then line number 17 got executed, so another box got created, and then 0x500 got returned to this one to start with. Okay, let me clear this one. Okay, so this was initial presentation. Now what happened on line number 19? Instead of hello, now we are assigning some other values. So we put a word. Now if you, so far whatever actually we discussed it, if we go with that approach, ideally what should happen in ideal manner, this should be changed. This hello should be changed into the word, but that is not how the string the string works in the C sharp. The reason being that string is immutable as per the the .NET runtime, and there are it treats string a little bit differently, and there is a fundamental reason behind it that why it does like that, right? It because of this there are a lot of other performance gain the CLR and .NET runtime does, and that is why what it does that every time you reassign another the constant another values, for example here what it does that it allocates another the object, it reserve another space, it creates another the data, another data copy within the heap every time you reassign a different values. So what it will do, CLR will create the reserve the space for the word at another location, and that is what 0x504 is here, and then it return to s1. Now in this case what happened now you have s1 and s2 both end up having the two different copies. So in some sense it works like a value type string within the C sharp. Okay, uh, so it's very interesting. Okay, this works a little different. Now I think code variation wise, so far, I mean, we covered some of the scenarios. Quickly, I want to show you two things. If we are not careful, what we can do, that there is a chances that in our code we can have memory leak. And the other two different scenarios are possible. In one case, we will end up having occupying all the heap space, and in another case, we will end up having occupying all the stack space. We will not have enough space, and therefore we can have the stack overflow exception. Let's cover the stack overflow exception first. So we have one function here within our main method. We are calling another function, and this function is have one parameter, and what this function is doing that it is calling itself. So in other words, it is a recursive call, but there is no exit condition, and it can happen, right? If you're not careful, and somehow our the exit condition or end condition is not happening, we will end up having the stack overflow exception. What will happen in this case, that the moment your main method is going to be executed, right? So your first the stack main stack uh, a section is going to be created. What actually it will do, this one, right? And then from here, the moment each call is going to happen, we will end up creating the same function again and again. And what actually it means, that we keep creating another frame, you keep creating another frame, so we keep creating a stack frame, which itself the takes some it utilizes some of the memory, and therefore our stack memory will be out of limit. I mean, we will not have much space. Now keep in mind, just to let you folks know, that in Windows platform, stack is normally the entire memory which gets allocated for a thread is 1 MB only. And the reason being that the idea behind stack is that the moment your function is finished, the .NET, the runtime reclaim that stack memory. So that is why you don't need a lot. Heap, however, the heap you need, the more memory. I have another actually, the video which I have created, the same topic, where I have gone in much detail. So if you folks want to understand a little bit more, please go through and take a look that episode where I have actually gone into much detail. This one I wanted to keep it a little bit short, okay? But long story short, right, you whole the stack the memory would be we will not have enough, and therefore you will end up having the stack overflow exception. uh, the same thing happen for the heap as well, right? So even I mean uh, in heap, normally heap share the most of the memory of a RAM person, but once again, I mean everything is having a limit, right? So if we are not careful, our entire memory within the heap can be occupied, and therefore we will end up having the memory leak. So let's take a look quickly. So here what is happening, that we are actually this is a main method, we are the creating the object, and then within this function what actually it is doing, that it is creating a linked list, and then it is allocating 1 MB space for for its purpose to store some data. Now in this case, I mean, if you take a look the carefully, and it will be very interesting if you take a look this whole memory utilization. What is happening, that the main stack main thread gets called, right? It gets executed, and then within that it's having this p object, which is a reference, right? 0x600, the one which you see here, and then it is pointing to this it is pointing to this location, which is end up having the creating another byte array again and again and again for 1 MB space. And it continues, if it's going to be continuous like that, what will happen, I mean, up to the 10,000 allocation. So this is, I mean, even, I mean, let's say we are not short of the memory, but the point is that we are having a memory leak. So having said that, I hope that I mean, that covers this series, and this episode. Sorry, I'm saying series, I mean this particular episode, this particular question. I mean, we covered the most of the the nuances which is related with related with value type and reference type. I hope that, I mean, this was the helpful for you guys. uh, and that's it for today, for this particular topic. If you folks they like it, please do subscribe this channel, step by step coding, for any for the next episode. Till that time, happy coding, and thank you.